Okay, functions. Work out the value of x when f of x equals minus 0.5. So, if fx equals minus 0.5, then that's fx equals minus 0.5 over here as well. In other words, x over 4 minus 3 equals minus 0.5. And I just have an equation to solve. I'm going to start by adding 3 to both sides, getting x over 4 equals minus 0.5, add 3 is 2.5. And then multiplying everywhere by 4 gets me x equals 10. And there's my first problem solved. Now we're asked to find the inverse function of g. Now to find an inverse function, we're going to swap the x and the gx. We're going to relabel the gx as g inverse. And then we're going to rearrange until g inverse is the subject. So, I'm going to do my swap. If gx equals 6x minus 7, and I literally just swap the x and the gx, I'm going to get x equals 6 times gx minus 7. This is not a mathematical rearrangement, this is a swap of two different labels. And now that I've done that, I'm going to relabel the gx as g inverse x to represent that I've changed it. Now I rearrange the function to make g inverse the subject. This is just like solving an equation. I'm going to add 7 to the other side, getting x plus 7 equals 6 times g inverse x. And if I now divide by 6 to get rid of that 6 from the g inverse, I've solved the question. G inverse x equals x plus 7 over 6. Remember that rearranging a formula is just like solving an equation, and we'll get more into that when we got more formulas to rearrange. So for the next question, it asks me to work out the value of x when hx equals f of 13. Well, hx is 2 to the power of x. F of 13 is 13 over 4 minus 3. And I can tidy all this up to say 2 to the power of x, 13 over 4 minus 3 can be worked out. 13 divided by 4 minus 3 gives me 1/4. Now we have to think about our laws of indices. If I want to solve an equation using laws of indices, everything has to have the same base number. 2 to the power of x, I would really like it if that equaled 2 to the power of something. So looking at the quarter, that is 2 to the power of minus 2. 2 squared is 4, and making the power negative puts that 4 underneath a fraction, 1 over 4. So 1/4 or 0.25 is 2 to the power of minus 2. We're now asking if 2 to the power of x equals 2 to the power of minus 2, what's x? Well, 2 to the power of this equals 2 to the power of that, so this equals that. X equals minus 2. So this complication has nothing to do with functions or rearranging formulas. It's just a sneaky bit of equation solving they've thrown into this topic. I've had to think about my laws of indices to do it, but the basic principle of the functions was saying hx equals 2 to the power of x, and f of 13 is what I get when I put 13 into here. So provided we can understand that, we understand the principle of functions, and the rest of it is just a sneaky laws of indices question. Now I'm asked to make q the subject of the formula p equals 2q squared. Well, remember this is just like solving an equation. This is just like solving, say, 10 equals 2q squared. I would start by dividing by 2, and then I would take a square root. So that's what I'm going to do. I'm going to divide by 2 on both sides. This gives me q squared equals p over 2. If that was a number, I could work it out, but I can't, so I leave it alone. The final step will be to square root everywhere, getting me q equals the square root of p over 2. And that's my rearranged formula. On to the next question. I'm given 3 functions to play with, and I'm asked to find f of minus 3. So this simply means put minus 3 into this f function. That is 3 times minus 3 minus 2. Notice that even here I'm being careful to substitute in my negative number using brackets. This gives me minus 11. Now I want to find the value of x when fx equals 19. fx is 3x minus 2, and I want to know when that equals 19. So I'm going to add 2 to the other side, making 21, and divide by 3 to get x equals 7. Now I'm asked to find fh2. Now fh is the function we get when we compose together the f function and the h function. This is best thought of as f of h. F of h is 3h minus 2. But h is actually 3 to the power of x. So that is 3 times 3 to the power of x minus 2. This is not the same thing as 9 to the power of x. So leave it as 3 times 3 to the x minus 2. So I want to know what fh of 2 is. This thing over here is fh of x. So fh of 2 is 3 times 3 to the power of 2 minus 2. That is 27 minus 2, which is 25. So, in the next part of the question, we are asked to find gfx plus fx plus x in its simplest form. So once again, I'll come up here for this bit. gfx is g of f of x. G is x squared. G of f is f squared. But f is 3x minus 2, so f squared is 3x minus 2 squared. Okay, so that's gfx. Let's substitute this in. 3x minus 2 squared plus fx, which is 3x minus 2 plus x. To give the answer in its simplest form, I will multiply my brackets and collect like terms. 3x minus 2 squared is 3x minus 2 times 3x minus 2. That is 9x squared. Minus 6x minus another 6x is minus 12x plus 4. Plus another 3x and another x plus another 4x minus 2. Altogether then, that's 9x squared minus 12x plus 4x is minus 8x plus 4 minus 2 is plus 2. And that's the simplest form. Now I'm asked to find f inverse x. Remember those jobs? Swap, relabel, rearrange. I have to swap x and fx. So my first step is to write x equals 3fx minus 2. And I've swapped. I'm going to relabel the fx as f inverse. Relabel. And then rearrange to make f inverse the subject. Essentially, this is solving the equation to find out what f inverse x equals. And I'd start, as always, by getting rid of that 2 to the other side. So 3f inverse x equals x plus 2. Then I'm going to divide by 3 everywhere to cancel out that 3, which means f inverse x equals x plus 2 over 3. In the next question, I'm asked to make x the subject of this formula. Now, if I was solving the equation, the square root of x squared plus 1 equals, let's say, 5, the first thing I would want to do would be to get rid of that square root sign, which is trapping all my terms. I would do this by squaring both sides. And that's exactly what I'm going to do here. I'm going to start off by saying y squared equals x squared plus 1. Now, if I was trying to get to x, I would want to subtract the 1 on the other side. I would want to say x squared equals whatever y squared is, minus 1. And then, of course, I would have to square root. X equals the square root of y squared minus 1. And I'm finished. Again, rearranging formulas is just solving equations, and I'm just pretending that all my letters work like numbers. Now I'm asked to rearrange y equals 2x minus a over x to make x the subject. Now this one is going to be one of the most complicated ones that we do, because x appears twice. So, the first thing to do here is realize that that fraction isn't anyone's friend, so I'm going to multiply through by the denominator, as always, to get rid of it. My next line is therefore xy equals 2x minus a. And to save some time, I'm going to multiply out those brackets as I go. 2x minus 2a. Now if I want to make x the subject, I want x on the left-hand side wherever it appears. So I'm going to move the 2x over, saying xy minus 2x equals minus 2a. Now, if this was 3x minus 2x, I could just collect the terms. But I can't do that, because I've got xy minus 2x. I have a y and a 2. I do the next best thing to collecting now, which is I factorize out the x. Now remember that y minus 2 is just some number, and in order to get rid of that number, I'm going to divide by it. I'm going to divide on this side by y minus 2 to cancel it out, which means I'm dividing on this side by y minus 2 as well. So my final answer is x equals minus 2a over y minus 2. And the rest of the solutions are going to appear on the next video.